Let's discuss a question from engineering mechanics. So basically a pulley system is given and there are two masses of 0.36 kg and 0.72 kg around the pulley which are held together by a string. Now just before the system is released, the other masses, so they will be stationary. Now once the system is released, obviously the higher mass which is this will tend to go down, and the lesser mass will try to go up. What we do is we try to take a free body diagram of the individual masses. So let's take free body diagram of M2. So M2G is like this, where this is the weight and the tension in the string is T. So these are the forces acting, and we assume that it moves with acceleration. So the inertia force is M2A. This is the free body diagram of mass M2. Now coming to the mass M1, which is on the right side, tension T is upward and the gravitational force is downward, M1G, and the inertia force of this will be upwards because it moves upward, M1A. Okay, so now we'll just use a Newton's second law for each of the system, that summation of force is Ma. So for the mass M2, we assume that the upward direction is positive. So all the forces we take in that, for mass M2 we will take the downward direction positive because the acceleration is then downward. So it's always better to take all the forces in the acceleration direction. So M2G is positive because it's downward, T is upward, and is equal to M2A. Okay, so the additional gravitational forces, the gravitational force minus tension, that is the unbalanced force that provides M2A. Now for M1, what we need to do is we need to write down in the same way. So it is basically upward. Now because the acceleration is in the upward direction, and it doesn't matter the sign convention, whatever direction you have to use, the corresponding sign you have to use for MA also. But what we are doing is we are applying in the direction where M1A is positive. So assuming that upward direction is positive, so T minus M1G is equal to M1A. So these are the two equations. Now we need to find out the work done by the tension on 0.36 kg in 1 second. So basically, let's see how much is the acceleration. There are two unknowns here, tension and acceleration. Both can be found out. So let's add first both of them. So then it will be M2 minus M1G by M1 plus M2. So this is your acceleration. Okay, and so this will be actually 0.72 minus 0.36 by 0.72 plus 0.36. Okay, so this comes basically G by 3. Okay, so this is the acceleration. And now if you go back and substitute in one of the equations, let's substitute in the second equation. So T is M1 G plus A and A is G by 3. So it will be 4 M1 G by 3 is the tension. So we know the acceleration is constant throughout the process, right? Acceleration is constant. So the distance traveled by M1G will also be constant. So that is half, because initial velocity is 0, so half AT square. So half G by 3 into in 1 second, so 1. So it is G by 6. So work done by the tension will be same on either of the blocks. So on the smaller blocks they have asked, so work done by the tension is nothing but force into distance, and because the tension direction and the distance traveled are in the same direction for the 0.36 mass, so the work done will be T into S. Tension is 4 M1G by 3, okay, into distance is G by 6. So now we'll substitute everything. 4 by 3 into 0.36 by 3 into G is 10 into 10. by 6. So let's substitute everything and let's see how much we get. Okay, so 3 and 6 is 18, that gives here 0.2 and 0.2, 0.02 in fact. So okay, I mean 0.12 and 0.02, and because of 100 it gets 2, so basically 8. So 8 joules is the answer actually. So work done by the tension is 8 joules. The magnitude of the work done by the tension is 8 joules. And it is positive because on 0.36 the work done by the tension is positive. Okay, so 8 joules is the answer. So this is basically engineering mechanics problem where you have to just apply the Newton's law, get the acceleration, and because it's constant, so you can apply our kinematic equations ut plus half at squared, so that you apply, you got g by 6, and then you just compute the work. Thank you.